It's just a curiosity, really. It's that answering questions that nobody else has asked or has found the answers to. It's that exploration into, the fundamental truth and chemical makeup of the planet, people. That's really what's driven me. My research for a long time has been understanding interaction between metal ions and proteins, trying to understand how we can move electrons around using biological molecules, how proteins and the metal ions within them control electron transfer in complex systems before we can use them for any particular application. Our real applications are, we think, is in the growing field of synthetic biology, where people can engineer microorganisms for designing and constructing metabolic pathways to make useful products, useful chemical products. I think the people in the field believe that this is the future for high-value chemical production and perhaps even bulk chemical production. There is an industry already developed on the basis of synthetic biology. What we hope to be able to do is to provide orthogonal systems that can be plugged in to microbial production of chemicals. We're currently active in two areas. One is based on my traditional interest of heme proteins, collaboration with David Wales' group, who do large, thousands of atom calculations to understand the interaction between cofactor and protein. We're examining a new activity that we've uncovered in this protein. These are microbial proteins that are involved in ion acquisition from hosts, often found in pathogenic bacteria. There's a whole suite of proteins that are involved in acquiring heme from the host, say a mammal's blood, taking heme into the cell and either keeping it as heme or breaking it down into iron. So we've discovered some unusual reactivity. Traditional experiments couldn't quite uncover how this system works, and that's where we engaged with David Wales' group. It has given us predictions of reaction pathways that we can then test experimentally. We're aiming to recruit into that area to extend our ability to engineer heme proteins for electronic purposes, particularly the covalent attachment of porphyrins to proteins is something I've been interested in for many years. And the other project is the artificial metalloenzymes, where again we've been doing very fundamental systematic experiments to understand how organometallic cofactors, synthetic abiological organometallic cofactors, principally based around ruthenium, understand how they interact with proteins. We do this in collaboration with Florian Hohlfelder in biochemistry, who uses microfluidic selection systems for finding active catalysts from libraries of 10 to the 6 or 10 to the 7 different sequence possibilities. My group is multidisciplinary. We do some very relatively straightforward but fundamental inorganic synthesis of some new compounds, new ligands to form metals. And then in the biochemistry lab, we do protein engineering and library construction using molecular biology, a lot of protein purification and biophysics to understand how these things assemble. Interdisciplinary and multidisciplinarity comes from asking questions that require results from different fields that you don't know anything about to be able to answer them. And so, by asking questions that are outside your current expertise, you get forced to go and talk to the experts in different fields, but you need to be able to communicate with them. So it forces people to understand, at least at some expert level, exactly how other techniques, how other ways of thinking work. I started out as an organic chemist, but then I realized there were a lot of interesting questions in biology. So although I wasn't very good at it, I forced myself to become a biochemist. We want to encourage all the group to think outside of their comfort zone to be able and not be afraid of thinking and reading in an area for which they're initially don't have any experience. Although we're a relatively small group, we cover quite a wide range of techniques. And that's actually a fundamental philosophy of mine, is always to work at the boundaries between techniques, so that students and postdocs who work in the group develop an expertise in a variety of groups, not just one central expertise, but understand chemistry of the system from a variety of different perspectives. And therefore it takes a variety of people from different backgrounds to contribute to these kind of projects. So we really are a big team effort, trying to bring together a lot of different things to answer fundamental questions that we hope will lead to technological advances.